everybody, welcome to 6C, chapter 6.3 in the textbook, Graphing Using X-Intercepts. So, in this chapter, we're using X-intercepts to essentially draw parabolas, or sketch parabolas. Now, up to this point, you should know how to do this. In the last chapter, or sorry, not the last chapter, the last lesson, we talked about solving quadratic equations using X-intercepts. It's the same idea. So our job is to factor this first in order to find the x-intercepts. Now, 2 lessons ago we talked about finding coordinates of the vertex, right? Where we completed the square. Okay, now that is a skill. You are expected to know how to complete the square. In fact, let me just quickly go through this very quickly in order to find the coordinates of the vertex. Again, taking a look at the first 2 terms, the most I can factor out is a 1, which means I have x squared plus 8x, and then half of 8 will be 4, so it'll be plus 4 squared minus 4 squared plus 7. Okay. Now, from here I could immediately just write x plus, and then the square root of 16 is just plus 4 squared. And then I know 1 times negative 4 is just, negative 4 squared is negative 16. Times 1 is negative 16 plus 7, and then after completing the square, this is in vertex form. Negative 16 plus 7 is negative 9. Here's my vertex, negative 4, negative 9. Now, that'll be coordinates of my vertex, so negative 4, negative 9. Now, how about the x-intercepts? So the x-intercepts will be, I'm just going to rewrite the equation over here, x squared plus 8x plus 7. My x-intercepts, my 2 numbers that will multiply to give me 7, but add to give me 8. And those 2 numbers are going to be 7 and 1. 7 and 1. Okay? Which means my x-intercepts are at 7 and 1. Okay? Now if I wanted to draw a sketch now, I should know that if I solve for these to find the x-intercepts, 1 would be at negative 7, 1 would be at negative 1, the vertex will be at negative 4, negative 9, which means it'll be down here. And we know because the a value is bigger than, it's positive, then I know that this is going to be facing up. And there's my parabola. Now, these are drawing skills from the last few lessons. Now, it says, find the x-intercepts and the coordinates of the vertex, then sketch each parabola. So you could use completing the square and factoring, or you could also, since I didn't specify that you had to complete the square to find the max or min, you could just simply find the x-intercepts first. So in this case, I need 2 numbers that will multiply to give me negative 12, but add to give me negative 1. Which in this case is going to be 4 and 3, 4 and 3, but it should be a negative 4 because that's a negative 1. Negative 4 plus 3 is negative 1. So then, I could split this negative x, which means I would get negative 4x plus 3x, which are these 2 numbers. And then I'm going to copy the rest of the equation down, which is 2x squared minus 6. And then once again, I could just do some common factoring, factoring by grouping. So out of these first 2 terms, I can factor out a 2x, which leaves me with just a single x in here. 4 factoring out a 2, which would leave me negative 2. Okay. And now for the second part of that equation, 3 and the 6, most I can factor out is, I guess, is 3. And then what am I left with in here? X, 6 divided by 3 is negative 2. And then I am done because these 2 in the brackets are the exact same. So I have x minus 2, and whatever is left over, 2x plus 3, 2x plus 3. Okay? Which means my x-intercepts are at x minus 2 equals to 0, so x equals to 2. And 2x plus 3 equals to 0, so that means 2x equals to negative 3. That means x equals to negative 3 over 2. Okay. So I could quickly try to draw the sketch of, I have an x-intercept of 2, an x-intercept of negative 3 over 2. Now, instead of completing the square, I also have the option of, if you think back to chapter 5, is I can look at these two, and I know my vertex lies on my axis of symmetry. So I could find the middle of these two numbers. Okay. I could find the middle of these two numbers. So that would mean, I'm just going to write it down here. So the axis of symmetry would then be 2 subtract 3 over 2, or sorry, add, but then because that's a negative, divided by 2. Okay. So that will give me 0.25 if you type that in your calculator. 2 minus a half, sorry, 2 minus 1.5 would be 0.5. 0.5 divided by 2 will give you 0.25. Okay. And then I can take this, because that would be my axis of symmetry, which means that it's down here. I'm just going to try. It's not going to be an accurate drawing, but down the middle here would be my axis of symmetry. Okay. Now to find the y value, then I just need to take the 0.25 and sub it back into the original. So instead of y equals 2x squared, I have y equals 2 times 0.25 squared minus 0.25 minus 6. And that should give me, if I just type this in my calculator, 2.25. Of course, it is preferred if you leave it in fractions. But just for argument's sake, I'm going to use a decimal, which will give me negative 6.125, which means my vertex is at 0.25. My vertex will be here on the axis of symmetry, 0.25 and negative 6.125. Okay, and of course this is facing up, so okay, and that's a horrible sketch, but you get the idea. So it's really up to you whether you prefer to complete the square to find the vertex, which I personally do, and factor to find the x-intercepts, or you can just factor, find the x-intercepts, divide by 2, add them and divide by 2 to find the axis of symmetry, which is the x value of your vertex, and then sub it into the original equation to get the y value. You can find your vertex that way as well. Okay, let's take a look at the next example. So what I'm going to do then is, complete the square, because I think personally, once you get used to it, it's much easier. So out of these first two terms, I'm going to factor out a negative 1. If I factor out a negative 1, I have x squared minus 6x, and then I know I'm going to be adding half of 6, which is 3 squared, and also subtracting 3 squared, minus 9. Okay. Then y equals, I know that my, when I factor that, it's going to be an x, copy down the sign, minus, and square root of 3 squared. Square root of 9, in other words, is just minus 3 squared. Okay. Now I need to bring this out, because negative 9 times negative 1 is plus 9 minus 9. Oh, beautiful. Which will give me my vertex of plus 9 minus 9 is plus 0. So my vertex is 3, 0. Okay. Now let's factor this to find the x-intercept. So y equals negative x squared plus 6x minus 9. So I need two numbers that will multiply to give me positive 9. Because clearly this is going to be complex factoring, because that's not a positive 1. So two numbers that will multiply to give me 9. Because negative 1 times negative 9 is positive 9. but must also add to give me 6. And they look like it's going to be 3 times 3 and 3 plus 3. So this is complex factoring, which gives me negative x squared. The 6x will be split into plus 3x, minus 9. And then I can factor by grouping, one group, another group. So I'm going to factor out a negative x, which gives me just an x, because it's x squared. If I took out one x, I have 1 left over. And then positive 3 divided by negative 1 is negative 3. I have that 1x, I factor that out. Over here as well, if I factor out a 3, I have an x. 9 divided by 3 is 3. Okay. Once you realize that these two are the exact same, you know you've done something right. X minus 3 and negative x plus 3. X minus 3 because they both have it, and then negative x plus 3 is whatever's left over. Now, what does this mean? Well, it means our x-intercepts are x minus 3 equals to 0, so x equals 3. That's one of my x-intercepts. Here's another, negative x plus 3 equals to 0. Now I'm going to move the x over instead of the 3, because if I move the x over, it makes it positive. So 3 equals x. Look at this. Well, what does that tell us? Well, that tells us that there's only one x-intercept, which is at 3, 0. So 3, and my vertex is also 3, 0. Well, how can that be? Well, this is my vertex, this is also my x-intercept, and this is my only x-intercept, which means I also know that negative 9 is my y-intercept, because in standard form. So if I look down here, there's negative 9. Now, in order for this to be my vertex and x-intercept, that means my graph must look something like this. Okay, and of course I want it to go through negative 9. And there you have it. Okay, so let me just scroll down some more. Okay, find the equation of the standard form of the parabola shown below. Notice how it gave us the x-intercepts, right? Which means I'm going to write it in factored form. So y equals a, x plus 2, and x minus 4. Minus 4 would imply the x-intercepts are positive 4. Now, it also gave us a point of 2, 16. So here's my y value, 16. Here's my x value, 2. So 16 equals a, and my x value is 2. 2 plus 2, and then x value is 2 again, 2 minus 4. And that could solve for a. So 16 equals a. 2 plus 2 is 4. 2 minus 4 is negative 2. And 16 equals a times 4 times negative 2 is negative 8. And divide both sides by negative 8. A will give me negative 2. Now, notice how I'm asking you to find the equation in standard form. So are we technically done? Not yet. But I can write this out in factored form. Negative 2 instead of a, x plus 2, x minus 4. Because I found out what a is now. And all I have to do is expand. So I'm going to expand just this part. X times x is x squared. X times negative 4 is negative 4x. Plus 2x plus 2x. Negative 8. Okay. Equals negative 2, and then collect like terms to have x squared. Negative 4x plus 2x is negative 2x. Negative 8. And I'm going to scroll down just a little bit more. And all I need to do now is expand the negative 2 in to give me negative 2x squared plus 4x plus 16. And that's in standard form. Done. Okay. And I think there's one more question, and this one's finished. Yep, one more question before the practice questions. An arc is going to be built. The design engineer uses the equation that, so I'm going to write that down. Negative d squared plus 16 to model the arc. where h is the height in meters above the ground and d is the horizontal distance in meters from the center of the arc. How wide and how tall is the arc? Now, I can imagine that the arc is going to look like a parabola. So if it's asking how wide it is, wouldn't it make sense for us to find the two x-intercepts? And that can tell us how wide it is. Now, since it's asking also how tall it is, then wouldn't it make sense for us to find the vertex? And that will tell us how tall it is. Okay? Now, we are all going to assume that the x-axis is going to be the ground. Okay? So, let's factor this first. You know what? No, let's complete the square first. Now, the problem with completing the square for this one is you're probably thinking, what? How? Because there's no d term in the middle. That's correct. So, what you could do is add plus 0d, but it seems unnecessary. So what we're going to do instead is we're going to factor this first. Okay? So I'm going to factor out a negative 1, the common factor, to get d squared minus 16. Once you're here, you should realize, oh, wait a minute, that's a difference of squares, which means d minus 4 and d plus 4. Okay, so what does that tell me? That tells me that my arc looks something like that, and that one x-intercept is going to be at negative 4, and the other one's at positive 4. So how wide is this arc from negative 4 to positive 4? 8 meters. So therefore, arc is 8 meters wide. Now, how tall is it? We need to find the vertex. So again, we can complete the square, and I did say earlier that I do prefer completing the square because it is easier. Now, however, if I look at this, wouldn't it be easier just to find the number that's between 4 and negative 4? Because that number between 4 and negative 4 is what? 0. Okay, so the axis of symmetry in this case is just 4 plus negative 4. Sorry, it's supposed to be a bracket. 4 plus negative 4 divided by 2. Wouldn't that give me 0? Which means the vertex is going to be 0 and then some number. But how do I find that some number? Just plug it into the original equation. So h equals negative d squared plus 16. H equals negative 0 squared plus 16, which just means h equals to 16. Okay. Now, therefore, the arc is 8 meters wide and 16 meters tall. Okay. Part B. If a width of 2.5 meters is needed per lineup at the entrance, how many lineups can there be? The design engineer, so we know that the width is going to be 8 meters, right? So, if the width of a width of 2.5 meters is needed per lineup at the entrance, how many lineups can there be? Well, 2.5 times 3 is equal to 7.5 meters, right? Which is just slightly under the 8 meter width that you are allowed. So therefore, there could be 3 lineups. 3 lineups. Perfect. Okay, so as always, if there are any questions, please post under math questions. Alright, take care.